Alright guys, so if you're looking to know what a force is, this video should be for you. So back in the day, now I sound old, back in the day, a force was defined as a push or a pull. Okay, so if an object pushes, very loosely of course, pushes or pulls on another object, that we call that action of pushing or pulling is a force. Now I want to kind of build on that a bit and make it a bit more professional and say, you know what, a force is the strength of an act, the magnitude or the strength of an act that causes an object to change or alter its motion. Okay, so if an object is at rest, meaning if an object is stationary, okay, the amount or the strength or the amount of change to that rest would be considered the amount of force that's been applied. So if you have someone sitting down or someone on a couch, okay, and someone comes along and lifts that couch, I could say that the magnitude of that push upward on that couch would be directly represented by how high that couch is off the ground. Okay, that would be the force that is applied to the actual couch. It's the amount that lifts the couch from a certain distance from its original position. Okay, so it's the strength of that applied force, let's say. So that would be the magnitude of that force on that couch with me sitting down on it. Okay, so that is a force. So it's really just the strength of that push or pull that causes an object to change its motion. So the more the object changes its motion, so the more the object changes its motion, okay, the more the object changes its motion, the stronger the force applied to it. That's the idea. So if someone applies a force and I am lifted higher and higher up, the force that was applied to me is much stronger than the original force that was applied if it was causing a shorter displacement upward. Okay, so the more the object changes the motion, the stronger the force applied. So that's basically what a force is. You have different types of forces in nature. One really important force that I want to talk about is gravity. Okay, so gravity is a type of force. So types of forces. You have gravity, gravitational. Gravitational is more of a pull force. It is attracting. Okay, so you and I might have a gravitational attraction toward each other, and we can actually quantify it, which we'll get to later. But that is a type of force, the gravitational force. You could also have the electromagnetic force. Electromagnetic force is a force that is either a push or a pull, again depending on what charges you're talking about. If you're talking about opposite charges, that will cause an attraction. Okay, so there's attraction, which you've, I'm sure, heard of before, attract, and there's like charges. Okay, like charges will repel each other. So this is repulsion, repel. Okay, and that just means between them, right? So they repel each other. So there are forces like that in nature. There are weak and strong nuclear forces. So the weak nuclear force, and there is a strong nuclear force. Now, I'm not going to get into it right now, but these are also forces in nature that are important and will probably be discussed in a future video. But as for right now, the most important force that we can think of is gravitational. So what you can actually do with the gravitational force is you can calculate the amount of gravitational attraction between two objects. So gravitational force. And this is a classical perspective. So this is Newtonian. So this is Newtonian physics. What I say is that if I have two objects, let's say the Earth, okay, and you got the moon. If I knew these two objects' masses, which I do, then I can determine the amount of gravitational attraction between the two. Now, you can do it using an equation, okay? So the equation is the following. This is called the universal law of gravitation. Fg equals g m1 m2 over r squared. And what we're going to do is we're going to talk about what each of these variables represent. So this is mass of object 1. Okay, so the first object. This would then be mass of object 2. R in this case, guys, is the separation distance between the two objects. So the two objects we're considering. Okay, and G is what we call a universal constant. It's a constant meaning that it's a value that just doesn't change. So this is a universal constant. Now the value of G, since it doesn't change, is 6.67 times 10 to the negative 11. Okay, now if we had the separation distance between the Earth and the Moon, and we had the two masses of the Earth and the Moon, so if we had this guy's mass, and we had this guy's mass, and we had the separation distance between the two, and we have this constant now, then we can determine the magnitude of the force applied between them, Fg. So let's try that. So what is the mass of the Earth? The mass of the Earth, if you just run it through Google, okay, it's hard to remember it after all these years. Mass of Earth. And just remember that we want to do standard units, and the standard units for mass are actually kilograms. So the mass of the Earth, okay, and that's what that E stands for, mass of the Earth, is 5.97 times 10 to the 24 kilograms. Okay, now what is the mass of the Moon? You can also run that through your Google search. Okay, the mass of the Moon is equal to 7.35 times 10 to the 22 kilograms. Okay, these are large masses. That means that you've got 597, and this would imply I'd have 22 zeros after 597. Okay, that is a lot. That is a huge mass. Okay, what is the separation distance between the mass and the Moon? So we need that quantity. So we need the separation distance between the mass and the Moon. Again, you can also run that through Google. Between mass and Moon, here we go. Okay. Not finding it so far. Here we go. Distance to the moon. Distance to the moon, 384,400 kilometers. Okay, in meters, guys, that's 384,400,000. So it's 384 million meters, 400,000. Okay, there you go. That many meters. That's the separation distance. All you have to do now, guys, to calculate the magnitude of the force between the Earth and the Moon is plug in the values to your equation. So here we go. Fg equals 6.67 times 10 to the negative 11, 5.97 times 10 to the 24 kilograms, 7.35 times 10 to the 23 kilograms, or 22, excuse me, divided by 384,400,000 squared. Okay? Once you plug that all in, you're able to determine the actual magnitude of the force on the moon. Now I'm going to pull up my trusty calculator and I'm going to start calculating. So I'd start by the denominator and I'd multiply it out. 6.67 times, let's see, exponent negative 11, 5.97 exponent exponent 24, 7.35 exponent 22 divided by 384,400,000, and you get the following magnitude. You get Fg equals to 1.981 times 10 to the 20 newtons. Okay, so it's that much. So this is the actual force between Earth and Moon in newtons. Okay. Now you can also determine what that means relative to, let's say, force between, you can also compare this force to, let's say, the force of an impact of a car or force of an explosion. So force, I'm just searching this up on Google temporarily. So force applied by explosion. I don't know how true this is, though, or if anyone's actually calculated it. I don't think anyone has. That sucks. In a rigid body. No, I don't think anyone has. That sucks. Okay. Well, it would have been nice to compare this force to force applied by something else. Let's say an explosion was, 100,000 newtons, right? Then you could figure out how many explosions this would be equivalent to, or things like that. But anyways, we'll leave it at that for now. And I hope you enjoyed this video. Hope it was informative. Hope it made sense. And I hope I didn't make any mistakes, although that can happen. It looks like I might have basically overdone the actual value. I think that exponent might be too much on the final answer, just because I know that gravity is somewhat of a weak force, and let's see, divided by, no, I could be fine. Let's see. No, I'm good. Okay, so that is the force between Earth and Moon in newtons. All right, guys, hope this was informative. So that's a force. That's an example of us calculating a force, and it's gravity, which we will be talking about more in future videos. So thank you so much, and if this was informative or helpful, don't forget to like and subscribe, and I'll see you in the next one. See ya. Peace.